Welcome back to Math 1300. This is Nunez Community College. We are finishing up section 7.4, which is inequalities. Okay. When we left off, we had to solve the inequality and graph it and use interval notation to write our answers. So it says solve and write an interval notation if we have 2x is greater than or equal to 8. 2x is greater than or equal to 8. Well, if this was an equation, we would solve it by getting the x by itself. So we would what? Divide by 2, cancel them out. X is still greater than or equal to 8 divided by 2, which is 4. This is the inequality. If they tell us to write it in interval notation says that x is greater than or equal to 4. So that means we start with 4, and greater than or equal to means we don't stop. We go on forever, so it's to infinity. The greater than or equal to means it's equal to, so it's going to be a bracket, and the infinity is going to have a parentheses. This is the interval notation. Okay? Now, if we're trying to graph this, the graphing is on a number line where we have 0. We then position the 4 where it would be on the number line, which would be to the right of 0. We'll have that as 4. It's greater than or equal to, so it's going to be a bracket, and the bracket's going to be facing the way that it's shaded. It's shaded towards infinity, so it's going to be a bracket, and we're going to shade it towards infinity. So we're solving. This is the inequality. This is interval notation. And here we have the graph. Okay, for the next one, we have the same things to do. But the next one, we have 5x is less than 15. 5x is less than 15. So we would divide by 5 to isolate the x. We have x is less than 15 divided by 5, which is 3. This is the inequality. For the interval notation, it's less than 3, which means we would end at 3. Less than 3 means we would start at negative infinity and go all the way to 3. Negative infinity, just like positive infinity, has a parenthesis, and it says less than 3, so that's also a parenthesis. If we have to graph this on the number line, we have our 0. 3 is to the right of 0. We're going from 3 to negative infinity, or negative infinity to 3, so it's going to be a parenthesis facing to the left because we're shading to the left. This represents negative infinity.
I didn't get that. Could you try again?
Sorry, y'all. Now, for the next one, it's a little bit different in what you have to do. We have negative 3x is greater than 9. Well, it's not really a big deal. It's the same thing we've been doing. What are we going to do? We want to isolate x. I have to get rid of the negative 3. So I divide by negative 3. I divide by negative 3. Here the 3's and the negative cancels out, so I have x. And this is what? Negative 3. 9 divided by negative 3 is negative 3. However, when multiplying or dividing by a negative number, the inequality sign switches. That's my little symbol for switches. So instead of it being greater than, it now becomes less than. So make a note of that. If multiplying or dividing by a negative number, we flip the inequality. we flip the inequality. So if this had been less than, we would have flipped it to greater than. Since it's greater than, we flip it to less than. And when trying to put it in interval notation, this says what? X is less than -3. So we end up with -3. Less than is negative infinity. It says less than, so that's a parenthesis, and we always put a parenthesis on the negative infinity. Graphing. Here's my 0, -3. It's a parenthesis. Whatever you have here is what you put on the graph, so that's a parenthesis, and we're shading to the left. Shading to the left. All right, the following one, they want us to put it in set builder notation. They want us to put it in set builder notation. Remember, that's the x such that. The x such that. Write it in set builder notation. We have 2x minus 9 is greater than 4x plus 5. Well, just like the equation or the equality, we're gonna have to take the x and put it on one side or the other. We're gonna bring the small x to the large x. Well, yes, but when it comes to inequalities, most people want to leave the x on the left. Because if you leave the x on the left, you read it as x is greater than or x is less than. So for this, we're going to always make sure that we try our best to keep the x on the left. So I'm going to subtract 4x. Subtract 4x. They cancel out here, but 2x minus 4x is negative 2x. Minus 9 is greater than 5. Okay, I know I don't like to have the variable negative, but in this case, we're going to have it negative for now. We'll take care of it in a little while. So what? Take the 9 to the other side. I got negative 2x is greater than, I'm adding 9, so that's 14. I'm now going to divide by negative 2, divide by negative 2, cancel them out, and x, and this is what? Negative 7. But remember, we divided by a negative, so this flips. Instead of it being greater than, it becomes less than. X is less than negative 7. X is less than negative 7. So if we want to put this inequality in the set builder notation, this way we have it right here is how we're going to put it in set builder notation. We got the braces. It says x such that x is less than negative 7. That would be our answer in set builder notation. Alrighty. Again, we're just going to keep on expanding on this just like we expanded on the equations. They're really kind of the same thing. We're just adding more fluff to it, if you will. So I have 5 times x minus 2 in parentheses is greater than or equal to 9x minus 3 times 2x minus 4. 2x minus 4. Well, same things. We have what? Parentheses, and we have a number multiplied by it, so we're going to distribute. I'm going to distribute to the first, I'm going to distribute to the second. So that's going to be 5x minus 10, because I have to multiply by the negative 2, is greater than or equal to 9x, but then I'm going to multiply the negative 3 to both of these, so that's negative 6x plus 12. Once I'm doing this, again, it's the order that we have. I have x's both on the right, so I'm going to combine them, called combining like terms. So I'm going to have 5x minus 10 is greater than or equal to 3x plus 12. Now, since it's an inequality, I would like to bring my x's to the left. It just so happens I am bringing the small x to the large x, so minus 3x, cancel, cancel, giving you 2x minus 10. Now remember, I subtracted x. I did not multiply or divide. So subtracting and adding, I leave the inequality as the exact same way that it is. So that's greater than or equal to 12. Now we're back to this situation. I'm going to bring the 10 over, so 2x is greater than or equal to 10 plus 12, which is 22. divide by 2, divide by 2, x is greater than or equal to 11. X is greater than or equal to 11. In this one here, they're giving it in interval notation. So this written in interval notation, x is greater than or equal to 11, so we start with 11, and greater than keeps on going, so it goes all the way to infinity. Greater than or equal to has a bracket, infinity always has the parentheses. Infinity always has the parentheses. And then finally we have the last one on this particular section. And it's a nice one because it is a fraction. Solve and write using set builder notation. So we're using set builder notation. I have 1/6 minus 3/4 x. 3/4 x is greater than 11/12. Greater than 11/12. Well, we're not going to change. We are going to get rid of the fractions if possible. So we want to find our least common denominator. And I know that y'all see me put down least common denominator, you put in the numbers and I just tell you what it is. That's because we kind of should know how to find a least common denominator. But if we're trying to do it, I would take my numbers 6, 4, and 12, because that's my denominators. And I would write each one of them using the prime factors, meaning the lowest numbers that we have to multiply to get that. 6 would be 2 and 3 as my prime factors. 4 would be 2 and 2 be my prime factors. And 12 would be 2 times 6, which is 2 times 2 times 3. Now, my least common denominator is going to be the most that I see in any particular space that we have. So if I have a 2 as my least common denominator, that would be fine. I got a 2 right here, so I know I at least got a 2. I come down here and I got a 2, which I already put, but I got another 2. So I would put that 2. I come down here, I got a 2. Well, all right, I already have a 2. I have a second 2, but I already got a second 2. All right, so that takes care of all of our 2's. The most I can take from any particular one is 2 of them, so I have 2 of them. My next number is a 3. Here I have 1 of them, so I know I can take at least 1. Here I have none of them, so I know I'm going to take 1 if I have a choice. And here I have 1, so okay, I'll take 1. The most 3's that I have in any of these ones are 1, 3, so I'm going to take that. This multiplied together is our least common denominator. 2 times 2 is 4, times 3 is 12. So 12 is our least common denominator. That means that that's the number we're going to multiply each one of the terms by in order to get rid of the fraction. So I'm going to multiply by 12 to 1/6. I'm going to multiply by 12 to 3/4 x. And I'm going to multiply 12 by 11/12. And since we're multiplying, we can cancel. And so we say what? 6 goes into 12 2 times. 2 times 1 is 2. So that becomes 2. Minus 12 divided by 4 is 3. So I got 3 times 3 is 9. X is greater than, here the 12 can cancel with the 12, leaving me with a 1. 1 times 11 is 11. We took the fraction. Now we have no more fraction. Now we can just solve it as our inequality. So what are we going to do? I'm going to take the 2, bring it over here. So subtract 2. I got negative 9x is greater than 9. And now what? Divide by a negative 9. Look what I'm doing. Dividing by negative. So it's going to flip the sign. This cancels out, giving me x. We flip the sign and we got what? Less than negative 1. X is less than negative 1. It said that it wanted the answer in set builder notation. The inequality is already kind of in set builder notation. We write it as x such that x is less than negative 1. If it had asked us for the inequality, less than negative 1 means we end at negative 1. Less that would be negative infinity. that would be a parenthesis, that would be a parenthesis. Well, this concludes section 7.4. I hope that it helped you out. I'll see you on the next one.